Okay, so here are the examples for today's lessons, which are chapter 11.1 and 11.4. The first lesson will be over direct variation, which is 11.1. So let's do a couple of examples over that, and then let me know if you have questions. So I guess here's three formulas that you should be familiar with. The first one says, if x varies directly with y, then this is the formula that we're going to use. X equals ky. Directly just means that if y goes up, x will also go up. Or if y goes down, x will also go down. Here, k is called the constant of variation. The next formula is if x varies inversely with y, then this is your formula. X equals k over y. Inversely just means that if y goes up, x will go down. And then vice versa. If y goes down, x will go up. K is still the same constant of variation. And then finally, jointly, so that's the last one. If x varies jointly with y and z, that just means directly with like two variables. So here you would have x equals k, y, z. So if both y and z go up, then x will also go up, and then vice versa. So those are the three formulas that you need to be familiar with. Make sure you take your notes because you can use your notes on your first quiz in Delta Math. So let's try an example together. Number 1. The number of bags of grass seed, which is variable n, needed to reseed a yard varies directly with the area A to be seeded and inversely with the weight W of a bag of seed. Okay, so with that first sentence, I'm going to go ahead and write an equation. So I'm going to start with n equals, because that's your variable. It is directly related with A, so I'm going to use this first one, which K is called a constant of variation. A is the area to be seeded. But then your variable n varies inversely with the weight of the bag, so that means that here's what your formula will look like. N equals K, which is the constant of variation, A over W. And that just says that A is directly with N and W is inversely with N. So that's the first thing you want to start with. Now what we want to do is we want to solve for the constant of variation. So next let's do solve for K by plugging in the information that is given. So let me see. If it takes 2 3-pound bags, so 2 is the number of bags, so 2 equals, K is what we're looking for, 3-pound bags, so that's the weight. So if it takes 2 3-pound bags to seed an area of 3,600 square feet, so that's your area, 3,600. How many 3-pound bags will seed 9,000 square feet? So before we answer the question, we want to first solve for K. Seth, question.
Why is
Can you? Okay, so let's go ahead and solve for K here. We probably want to just reduce this and solve for K. So 3,600 over 3, that's like 1,200. So equals 1,200K. And then it looks like K would be 1 over 600. So I have now solved for K. And now, once you solve for K, here's what you'll do. You'll replace your K with the 1 over 600 in your formula. And after that, we should be able to solve for the actual question. So let me rewrite my formula. N equals. Instead of putting K, let's put 1 over 600, because that's what K is. The A is still the area to be seeded. And then the W is still the weight of a bag. Now we can answer the question. How many 3-pound bags, or how many bags that are 3 pounds? So let me start substituting. Yeah. So this W is still 3-pound bags we're talking about. So how many 3-pound bags will we need to seed 9,000 square feet? So the A here would be the 9,000. And now if you simplify that, that should give you your final answer, which is the number of bags. So this is like 9,000 over that. So those cancel. 18 goes into 90. 5 times. So 5 bags. And that's how you would do a direct variation. I'll pause for questions and then you can start. Okay. Number 2, same thing. The number of bags of mulch you need to cover a planting area varies jointly. So jointly is this one, with the area in square feet and the depth in feet. Okay, so this one is just a joint variation. The number of bags, I guess let's call it N again, varies jointly with area and depth. So you would write it like that for jointly. First, you need to solve for K. If you need 10 bags, so if N is 10, to mulch 120 square feet at a depth of 3, so this should be able to help you find K. So just multiply and reduce. This would be 10 equals 36. So it looks like K would be 1 over 36. Once you find the K value, go back to your equation and rewrite it with the K value that you just found. So N equals 1 over 36 times the area times the depth. And now you should be able to answer the question. Now it wants, how many bags do you need to mulch 180 feet? So we're looking for N. If you have 180 feet at a depth of 4 inches, that should work. So you just multiply and divide 180 times 4 over 36. So I think that's just 20 and then 20 bags. So definitely, I'll pause for questions. Definitely make sure you know how to do direct, inverse, and joint variation before you take your first quiz on Delta Math on your own. All right, next. Our next lesson would be 11.4, which is right here. And okay, so lesson 11.4 involves simplifying these rational expressions. So number 1, that's called a rational expression, all of these, and we need to simplify them. So the steps to simplifying rational expressions is, the first step is to always factor. That's why you were supposed to review factoring. So step 1, factor. We'll start with that. So that's what we'll do for all of these. The very first thing you want to do with simplifying these rational expressions is to factor. So let's start with number 3 and start factoring everything. X squared plus x minus 6 should factor into x plus 3, x minus 2. X squared minus 25 is a perfect square, so that should factor into x minus 5, x plus 5. Now on the denominator, I got a negative x plus 5. I know that doesn't factor, but I will take out the negative so that I can simplify it later with one of these numerator questions here. So negative x plus 5 will be negative parentheses, positive x minus 5. So I just took out the negative from these two terms and wrote it as negative parentheses x minus 5. That way I can simplify it with the numerator 1x minus 5 in a minute. And finally, let me factor the last one. It's probably just x plus 1, x plus 3. So step 1, factor. Step 2 is you cancel any factors that are the same on the numerator and denominator. So step 2, cancel same factors on numerator and denominator. On numerator and denominator. So for example, and make sure you show your work on your Delta Math quiz and upload it. For example, what are we going to cancel? The x minus 5, like I mentioned, that should cancel with the bottom x minus 5, because if you have a factor on the numerator that is the same on the denominator, that can be simplified and canceled out. Next, I have an x plus 3 and an x plus 3 on the bottom, so those can cancel out. And then the rest, I feel like nothing else can cancel. So for your final answer, if you leave it in factor form, my final answer will be, on the top I have x minus 2 times x plus 5. And then on the denominator, I have a negative parentheses x plus 1. So this would be your final answer in factor form. I think I have a little practice for your Delta Math quiz, or just read the directions on your Delta Math quiz when you take it later this week, because that would be the answer in factor form. But sometimes it wants you to write it like an expanded form, which just means like that numerator there should be like multiplied out to give you like a quadratic, like x squared plus whatever, 3x minus 10. Just read the directions carefully on your Delta Math quiz as to how to leave your answers, but this is an acceptable answer in factor form. That would be your answer. The last thing you will need to know for this lesson is something called state the restrictions on the variables. So the restrictions are just the denominator cannot equal to 0. Denominator cannot equal to 0. So when you have expressions like this with the denominator, your denominator cannot equal to 0 because in the math world you can't divide by 0. So what we need to do is we need to look at our denominator here on example 3, or any of the denominators, and make sure that they don't equal to 0. So I always start with my answer. X plus 1 is on the denominator. So that means that x plus 1 cannot equal to 0. That's one of the restrictions. Now I will simplify that and put that x cannot equal to negative 1. So that's like one of my restrictions. But there's more, because there were other factors on your denominator before you canceled anything out. So let me look at my work. So notice how there used to be an x plus 3 on my denominator. And even though it did get canceled, it is still part of your restriction. So x plus 3 is on the denominator, and therefore it cannot equal to 0. So that means that x cannot equal to negative 3. And there's one other restriction, so find x plus 1, I already have it. The other one, the other factor on my denominator was x minus 5. So that can't equal to 0. And therefore x cannot equal to 5. So these would be the restrictions for your answer for example 3. So make sure you know how to get the answer and make sure you know how to get the restrictions. I'll pause for questions before we try example 4. Okay, I guess let's try the next example. Example 4. The very first step when you're simplifying rational expressions is to factor. So let's factor 2 minus x. I'm going to factor the negative out of the x because I always like x to be positive. So let me take out a negative here. And this would be x minus 2 now. Yeah, so negative parentheses x minus 2. Let me do the denominator here. x squared plus 2x plus 1 is going to be x plus 1 squared. Okay, now here's one thing. Because this is a division sign, what you need to do is we're going to change that division sign to a multiplication symbol. And if I do that, I just need to switch my numerator with my denominator here. So I'm changing the division symbol to a multiplication symbol, and I'm going to flip my fraction. So that means that x squared minus 1 will go on the top here. But let me factor x squared minus 1. That's x plus 1, x minus 1. Right. And now my the numerator will now be on the denominator because I am switching the division symbol to a multiplication symbol. So let me factor x squared plus 3x plus minus 10. X plus 5, x minus 2. That looks right. Now you can do the same thing I did on example 3. Any factors are the same on the numerator as the denominator can be canceled. So this x minus 2 with the x minus 2. The x plus 1 on the numerator can be canceled with one of the x plus 1s on the denominator. You have a x plus 1 squared. So that means you have x plus 1 and times x plus 1. So let me just cancel one of those. So you're left with a single x plus 1. So again, your answer in factor form will be on my numerator, I have a negative, parentheses x minus 1. On the denominator, I have the x plus 1 to the first power times x plus 5. I think on Delta Math, you just leave your answer in factor form. I'm pretty sure. Just make sure you read the directions. So that would be your final answer in factor form. And now don't forget to list the restrictions. That would be like a separate kind of question if it asks you to list the restrictions. If not, then don't list them. But for here, it does ask us to list. So the restrictions are just check out the denominators and make sure that they're not equal to 0. So let's start with this one. X plus 1 cannot equal to 0. Solve for x. X plus 5 cannot equal to 0. Solve for x. And then don't forget to check anything that you might have canceled. X minus 2 cannot equal to 0. So my restriction should be x can't equal to negative 1. X can't equal to negative 5. X can't equal to 2. And I think actually I have one more. So before I flip the thing, x squared minus 1 was on the denominator. So technically this factor here, this x minus 1, I know it's on the numerator now, but it was on the denominator to begin with. So that one should also be a restriction. So let me put it on here. X minus 1 cannot equal to 0. So x cannot equal to 1. I didn't put anything like that or tricky on the quiz, but you should just know it. So again, this x minus 1, even though it is on the numerator, it's still going to be part of the restriction because in the original problem, this x minus 1 factor was on the denominator. So that's still going to be your denominator cannot equal to 0, which I think I forgot to include that on my answer key. So I'll go ahead and add it. So the restrictions are x can't equal to negative 1, negative 5, 2, and positive 1. I would pause for questions, but you probably don't have any. So we're just going to do number 5 now. Unless you have a question, you can raise your hand. Number 5 is going to be the same thing, except for that one we don't have to factor because it doesn't have an expression like the other ones. So here, let me pause for a question because one of them does. All right, so number 5 is a little bit different because you don't have to factor anything. So for that one, all we got to do is we need to like cancel everything that has any common factors. But first, let me change my division sign here at the very end. So I'm going to change that division sign to a multiplication by flipping only that last fraction. So I'm going to rewrite the question. 25u6v over 4w5 times 9v over 10 u squared w. And then let me switch the division to a multiplication and then flip the last fraction. So 2w7 over 15 u3 v. Okay, so for that one, the way I just do them is you start canceling any factors that are the same on the numerator with the denominator. So for example, it doesn't matter where you start. Let me start with this 25. So this 25 and this 10 have a common factor of like 5, I guess. So this would be a 5 now, and that would be a 2. What else? It doesn't matter which order you do it in. But another one is this 9 and this 15 have a common factor of 3. So that would be a 3, and that would be a 5. And then obviously this 2 can cancel either with the 4 here or with, I'm just going to cancel it with this 2 right here. Cancel that 2 with that 2. Same thing with this new 5 can cancel with that 5. So at the end of all this canceling for my numbers, for my integers, on the numerator, the only thing that was left was a 3. And on the denominator, the only thing left was a 4. So it's 3/4. Again, I just started canceling all the factors from 25, 9, 4, 10, and then the 2 and the 15. Now we'll do the same thing with the variables. So let's start canceling some of these. It doesn't matter how you want to do it. How did I do it on the answer key? Okay, it doesn't matter how you want to do it, but let's start with the u. So on the top, I have a u to the 6th. And on the bottom, I technically have a u to the 5th because I have u squared times u cubed. That's u to the 5th. So therefore, u to the 6th divided by u to the 5th will simplify to just a u to the 1st power. Because when you're dividing the variables like that, you subtract the exponents. So 6 minus 5 is 1. Now do the v. I have v and v on top, so that's a v squared. And then I have a v to the 1st on the denominator. So again, if you subtract 2 minus 1, that's just v. And we can do the last thing with w. I have a w to the 7th on the numerator. And then on the denominator, I have, already did that one. I have w5 and w1. So together, that's a w6. Subtract again, 7 minus 6 is still 1. So my final answer for number 5 should be, I guess 3/4 times UVW, or you can write it like that, 3 UVW over 4. So that's your final answer. That's what you would type in for your Delta Math. And then the restrictions here are still your denominators can't be 0. So if you look at all your denominators, W cannot be 0, U cannot be 0, and V cannot be 0. So basically all the letters can't be 0. And that finishes example 5. So unless you'll have any questions, we'll do the last example, and then that would be it. You'll do your homework. Don't forget your 2 Math Excel homeworks tonight. And then we'll continue chapter 11 on Wednesday. So, example 5. I guess let's just start factoring. Sorry, example 6. Let's just start factoring. So, n squared minus 1 would be n minus 1 times n plus 1. N squared minus 3n minus 10 would be n minus 5n plus 2. And now times n squared plus 5n plus 6 will be n plus 2 times n plus 3. N squared minus 3n minus 4 would be n minus 4n plus 1. Yep, and then the last one n squared minus n minus 20 will be n minus 5n plus 4. And then n squared plus 2n minus 3. N plus 3 and minus 1. Okay, so that's a lot of factors. Let me list all the restrictions before I start canceling, because if not, I forget. So remember, for your restrictions, your denominator, any of those factors, they cannot equal to 0. So let me just start listing my restrictions here. So n cannot equal to a positive 5. And then n cannot equal to a negative 2. N cannot equal to a positive 4. N cannot equal to a negative 1. And then n cannot equal to a negative 3. And then n cannot equal to a 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, there's 6 restrictions because of there's 6 factors on the denominator. Okay, now you can start canceling anything that matches on the top and the bottom. Like n minus 1 with n minus 1. N plus 1 with n plus 1. N plus 2 with n plus 2. N plus 3 with n plus 3. Does everything cancel? N minus 5 with n minus 5. Almost everything canceled, except for the n plus 4 and the n minus 4, because they have different signs. N plus 4 and n minus 4 is your final answer. And now that's how you do section 11.4. And like I said, now you have to go and practice your homework.